Okay, so this one is generally looks okay. It goes here, given that this exists, state the least value of k. Now that is a minimum point. If you was to draw that, you basically, you don't need to do this, but I'm just showing you why it works. If I went and draw that on a graph, let's just put that on a graph. You got x will be 3, that will be minus 7. So what happens here, this function will be something looking like that. Now that is the turning point, which is 3 along and down to minus 17 here. Now this is not a one-to-one function, so it won't have an inverse. But if it was to have an inverse, then this is the least value. It could be x would have to be greater than or equal to 3. Okay? So that only this function existed. Or less than, but they wanted greater than, so only that. So that means I'm going to rub this off. You no longer have that function. You only have this where you can work out. I'm just going to draw the axis back there. So yeah, that's very straightforward, where k is a constant. Find the least possible value of k, therefore k, the least possible value is x equals 3. That's done. Now next one is evaluate this. So if I put f in here, so f of 5, let's put that in first. 5 goes into there, which gives me 5 take away 3 squared minus 17. Now if I put that in there, that will give me 2 squared is 4, 4 take away 17 is minus 13, stop. Why would I stop? This cannot go further because we already made this claim. In order to be a one-to-one function, minus 13, x has to be greater than 3, so it will be invalid. So for b, just put f of 5 doesn't exist. As minus 13 is less than 3. Okay, so we had set a condition. It's pointless carry on because that's minus 3. Okay. Next one, C. So
I'll put that minus 13 back into the...
Yes, you could do, and then state it's not valid. It wouldn't have been valid for it anyway. So you could go back and work it out. I think you get 239, I think. But it won't be valid. So when it says evaluate, it's not a valid kind of term. If you did went and put it back in. Now, this next one, solve the equation where this is equal to x. Let's just do that. Now, there's no reasoning for this. You can just go and expand that out straight away. Well, actually, if I do x minus 3 squared minus 17 equals x, and then just do x squared, that minus 6x plus 9 minus 17. I'm going to take this x to the other side, make it equal to 0. And you can use your calculator from here if you want. X squared, that becomes minus 7x, and that plus that is minus 8 equals 0. Actually, you could just easily factorize that. 1 and 7. Sorry, 1 and 8. That's negative, that's positive. So x equals 8, or x equals minus 1. Solve the equation. Yeah, they both will work, so that's okay. X equals minus 1 or x equals 8. And D, explain why the solution in C is also a solution for that. Well, the simple reason is that you just need to do that when f of x equals f of inverse. Okay, they intercept at y equals x line. So when they intercept, where they intercept, all these three intercept, okay? You could say that f of x is reflected in y equals x to give f inverse of x. Okay, so it's a graph. If I was to plot it along here, where this graph is and this graph goes there, they will intercept at y equals x. We have the line of intersection. Okay, so that is f of, call that f inverse of x, and you call that f of x if you want. They will cross there.